Hello friends, today we will discuss questions related to transportation engineering which were asked in 2019 GATE examination. And in this session we will discuss questions which were in the first set, that is forenoon session. The first question reads like this: the coefficient of average rolling friction of a road is Fr and its grade is plus G%. If the grade of this road is doubled, what will be the percent change in the braking distance measured along the horizontal? Assume all the parameters are kept unchanged. Now here you must be knowing that the braking distance dB of a vehicle is given by this equation: v square upon 254 F plus minus G. F is the coefficient of friction, that is rolling friction, and G is the gradient. Now here, when G is changed from plus G to plus 2G, what will be the percent change in the braking distance? That is the question. So the first distance, let us say D1, is v square upon 254 F plus G. And second distance is D2, that is v square upon 254 F plus 2G. The difference between these two will be delta D, let us say, and that is v square upon 254 1 upon F plus G minus 1 upon F plus 2G. That is the distance difference. Or you can say v square upon 254 into F plus 2G minus F minus G upon F plus G into F plus 2G. Or this is v square upon 254 F into G upon F plus G into F plus 2G. Now, this is the change in the braking distance when gradient is changed from G to G. Now, what is the percent change? Percent change will be delta D upon original distance, that is v square upon 254 F into G upon F plus G into F plus 2G upon v square upon 254 into F into 1 upon F plus G. So this is now reduced to G upon F plus 2G. Because G is in percent and therefore G should be written as 0.01 G upon F plus 0.02 G into 100. That is the percent change. 0.01 G upon F plus 0.02 G into 100. And that is your answer. Answer number C. 0.01 G upon F plus 0.02 G. That is the first question. Now, second question is on concrete slab. It says that an isolated concrete pavement slab of length L is resting on a frictionless base. The temperature of the top and bottom layer is Tt. This is temperature of the top fiber is Tt and of the bottom fiber is Tb. Given that the coefficient of thermal expansion is alpha, the elastic modulus is E, and assuming that Tt is more than Tb, that is top surface is hotter than the bottom surface, and the unit weight of concrete is 0, the maximum thermal stress is given by this equation. There are three or four options. Now here this is frictionless. The slab is resting on a frictionless base. Now consider a slab which is resting on the subgrade or base course layer. When the temperature of the upper fiber is higher than temperature of the lower fiber, then this will expand more than this one. So it will be a curling of this type. Now this curling is resisted. The movement of the bottom layer is resisted by the friction between the base course and the slab. And that creates the stresses in the pavement. And because there is no friction here between the slab and the base course, so there will be no resistance offered by the base. So no thermal stresses. So thermal stresses will not be generated in this slab because there is no friction between the base and the slab. So answer is 0. No thermal stress. The third question is the maximum number of vehicles observed in any 5-minute period during the peak hour is 160. Vehicles in 5 minutes, and that is the maximum count. So you can say V5 maximum is 160 vehicles. The total flow in the peak hour is 1000 vehicles. Total flow is 1000 in 1 hour. Vehicles per hour. What is the 5-minute peak hour factor? Now peak hour factor is given by this equation. Peak hour factor is hourly volume divided by 12 into V5 max. Why 12? Because you are counting 5-minute interval. So there are 12 intervals in 1 hour, and therefore this must be 1000 upon 12 into 160 equal to 0.52. Now this is the peak hour factor. Question number 4 is that a concentrated load of 500 kilonewton is applied on an elastic half space. The ratio of increase in vertical normal stress at depth 2 meter and 4 meter along the point of loading as per Boussinesq theory would be. Now here Boussinesq theory says that when you apply a load on a pavement which is distributed over a radius of A or diameter 2A, then the stress at any depth Z will be given by, let us say this is sigma Z, then sigma Z is P into 1 minus Z cube upon A square plus Z square power 3 by 2. Now here A is the radius of loaded area. When it is a concentrated load of 500 kilonewton applied, then A becomes 0. When A becomes 0, this load is concentrated at this point. Now what Boussinesq says that when the area becomes 0, radius becomes 0, the stress at any depth will tend to be infinite. And when the stress is very high, then in that case the plastic and elastic flow of material will take place. In that case, the pressure in the soil mass will be in the form of pressure bulb. So this is the load here, concentrated load, and you have the pressure bulb appearing inside the mass. And at any depth, let us say Z, below the load surface, the sigma Z will be 3P upon 2 pi Z square. That is the equation to calculate vertical or normal stress in case of concentrated load. Now P here is 500 kilonewton. What basically you need to know, what is the ratio of sigma Z when the load is at 2 meter divided by sigma Z when load is at 4 meter. And therefore this will be inverse of the Z. So this will be Z 2 square 4 square upon Z corresponding to 2 square, that is 4 meter, that is 16 upon 4, 4. That is the ratio of stress at 2 meter and 4 meter when a concentrated load is applied at surface. That is question number 4. Question number 5. A parabolic vertical curve is being designed to join a rod of grade plus 5% with a rod of grade minus 3%. Now, this is the gradient of plus 5% and that is the gradient of minus 3%, let us say. And this is the vertical curve here. Now, the length of vertical curve is 400 meter measured along the horizontal. The vertical point of curvature VPC is located on the rod of grade 5. The difference of height between VPC and vertical point of intersection, that is VPI in meter, rounded off to nearest integer is. Now here, what basically it says that this is the point of intersection of two grades. This is VPI. Okay, that is vertical point of intersection. And this is the length of the curve, 400 meter. 400 meter. What is required here is, let us say this point is A, this is B, this is C, and this is, let us say, D. We need to know BD. What is the distance? BD. Now, this is 400 meter total length, so this becomes 200 meter. AB. AB is 200 meter. And this height will be achieved at a gradient of 5%, and therefore BD will be 5% of 200, that is 10 meter. That is the answer to this question. Question number 6. This question reads like this. A box measuring 50 centimeter into 50 centimeter into 50 centimeter is filled with dry aggregate of mass 187.5 kg. The water absorption of the aggregate is 0.5% and specific gravity is 2.5. Maximum quantity of water that can be filled in the box. Now, the size of the box is 50 centimeter into 50 centimeter into 50 centimeter, that is 125,000 centimeter cube, or you can say 0.125 meter cube. Weight of aggregate in the box is 187.5. Specific gravity of aggregate is 2.5. So, volume of aggregate will be 187.5 divided by 2.5 into 1000. That is the density of water. Okay. So, you have 0.075 meter cube. Now, remaining volume here is now 0.125 minus 0.075, that is 0.05 meter cube, or if you fill water in this, you will get 0.05 into 1000, that is 50 kg of water. 50 kg of water can be added into the box. And because 0.5% is the water absorption aggregate, so 0.5% water will be absorbed by the aggregate when you fill it with water. So what is 0.5% of 187.5 kg of aggregate? That is 0.9375 kg. 0.005 multiplied by 187.5, 0.9375 kg. So this additional water can be put. So total weight of the total water that can be filled will be 50 plus 9375 kg. And because answer is to be in 2 place of decimal, and therefore it will be 50.94 kg. Question number 7. Average free flow speed and jam density observed on a road stretch are 60 km per hour and 120 vehicles per kilometer respectively. For a linear speed density relationship, the maximum flow on the road stretch will be. Now this is a linear relationship. Now linear relationship is also called green shield theory, green shield equation. It says that V is equal to Vf 1 minus K upon Kj. I have a separate video on this topic. Now free flow speed is given. Free flow speed is 60 km per hour. Jam density, this is jam density, and K upon 120. Now this is the equation of flow. According to green shield theory, maximum flow occurs, maximum flow Q max will occur when speed is half of free flow speed, and corresponding to that, density will be half of jam density. Means it is Vf into Kj upon 4. This is given 120 upon 4, 1800 vehicles per hour. That is the maximum flow that can occur on this road. The next question, which is also of 2 mark. Traffic on a highway is moving at a rate of 360 vehicles per hour at a location. If the number of vehicles arriving on this highway follows Poisson distribution, the probability that the headway between successive vehicles lies between 6 and 10 seconds is. When the vehicle arrival follows the Poisson distribution, that is random phenomena, in that case, the inter-arrival time, that is headway, will follow exponential distribution. And when it follows exponential distribution, then probability of headway being less than or more than or equal to t will be given by e to the power minus q into t. T is the time interval which you need to know, and q is the rate of arrival. Now here, q is 360 vehicles per hour, or you can say that 360 upon 3600 seconds in an hour, that is 1 by 10 or 0.1 vehicle per second. Now this probability distribution follows this kind of CDF. This is the probability of headway being more than or equal to t, and this is time t. Now this is 6 seconds. That is the probability of headway being less than or equal to 6 seconds, where it is 6 seconds. Find out what is that. Probability of headway being more than or equal to 6 seconds is e to the power 0.1 into 6, 0.5488. Similarly, the probability of headway being greater than or equal to 10 seconds, 0.3768. This is the probability at 10. What you need to know, this area here. Total area is 1. Okay. So this area will be this minus this. So that is 0.181. And because it says rounded off to 2 decimal places, so the probability of headway being 6 to 10 seconds will be 0.18. That is the answer. And the last question in the forenoon session is again on concrete pavement, and it says that tie bars of 12 millimeter diameter are to be provided in a concrete slab. The working tensile stress of the tie bar is 230 MPa. Average bond strength between the tie bar and concrete is 2 MPa, and the joint gap between the slab is 10 millimeter. Ignoring the loss of bond and the tolerance factor, the design length of the tie bar in millimeter will be. Now, length of tie bar is given by this equation. 2 into SST into A upon B into PPTB. That is the equation. Now, this is allowable tensile stress. This is the cross-sectional area of tie bar. Cross-sectional area of tie bar. And this is allowable bond strength between the concrete and tie bar. And this is what we call the perimeter. Perimeter of tie bar. You can refer IRC 58 on design of concrete pavement for this equation. Cross-sectional area, because diameter is 12 millimeter, and therefore this will be pi by 4 into 12 square, 113.09 millimeter square. Perimeter will be pi into D, so this will be pi into 12, that is 37.7 millimeter. This is given as 2 MPa. This is given as 250 MPa. So you can calculate what is length. So length will be 689.94. You can say 690 millimeter. And because the gap is 10 millimeter, average gap, joint gap is 10 millimeters, you add 10 millimeter here. So the total length of the tie bar will be 700 meter. That is the final answer. So these are the questions which were asked in forenoon session of 2019 GATE. If you have any question, please write in the comment box. Thank you very much.